My name is Karen Jaimes, and in this work we developed multifunctional biopolymeric hydrogels loaded with zinc oxide nanoparticles and Morin for potential topical treatment of viral skin disorders. In this work, we prepared hydrogels based on gelatin, chitosan to provide biofunctionality, and arabic gum as a cross-linking agent. Zinc oxide nanoparticles and Morin were incorporated as bioactive agents due to their reported antiviral and antioxidant properties. As shown in the materials and methods section, zinc oxide nanoparticles were synthesized by co-precipitation, while hydrogels were obtained using a freeze-thawing method. Then zinc oxide nanoparticles and Morin were encapsulated into the hydrogel matrix using ultrasound. Different characterization techniques were performed to evaluate the physicochemical properties of the materials. Starting with Fourier transform infrared spectroscopy, characteristic bands corresponding to Morin, zinc oxide nanoparticles, and the hydrogel matrix were identified, confirming the successful incorporation of both bioactive compounds into the polymeric network. Regarding wettability, contact angle studies demonstrated that zinc oxide nanoparticles and Morin modify the surface properties of the hydrogels. In particular, Morin increases hydrophilicity due to the presence of hydroxyl groups capable of interacting with water molecules. Swelling studies showed that all hydrogels exhibited high swelling capacity under simulated skin conditions. However, the incorporation of zinc oxide nanoparticles and Morin reduced the swelling degree due to poor blockage and interaction within the matrix. Thermal analysis demonstrated that zinc oxide nanoparticles improved the structural stability of the hydrogels through nanoparticle polymer interactions. In the release study, we evaluated the release of both Morin and zinc oxide nanoparticles in acetate buffer at pH 5 and 32 degrees Celsius, simulating skin conditions. Morin exhibits a sustained release profile and followed zero order and Korsmeyer-Peppas kinetics models, indicating that the release mechanism was governed by diffusion, polymer relaxation, and matrix erosion. In contrast, nanoparticles showed a limited release profile, suggesting that a large fraction remained retained within the hydrogel network. This is important because zinc oxide nanoparticles not only provide therapeutic activity, but also improve the structural stability and reinforcement of the material. Regarding therapeutic properties, antioxidant activity was evaluated using the GPPH assay. Hydrogels loaded with zinc oxide nanoparticles and Morin showed significantly enhanced radical scavenging activity compared to the unloaded matrix, whose antioxidant capacity is mainly attributed to chitosan. Virucidal assays against herpes simplex virus type 1 and bovine coronavirus, both associated with skin infections, demonstrated promising antiviral activity. The combined incorporation of Morin and nanoparticles contributes to antiviral performance of the hydrogels, reaching very high inhibition percentages for both viruses. Finally, micrograph also showed that Morin and nanoparticles modify the hydrogel morphology, increasing surface roughness and promoting compact domains within the polymeric network. Overall, these results demonstrate that zinc oxide nanoparticles and Morin were successfully incorporated into biopolymeric hydrogel network, providing sustained release, antioxidant activity, promising antiviral activity against herpes simplex virus type 1 and bovine coronavirus, and structural stability, highlighting the potential of these hydrogels as multifunctional platform for topical antiviral applications. Thank you for your attention.